name is Juhana Helovuo. I come from Atostech in Hervanta, and today I'm talking about the robot operating system 2 and some things attached to it, and doing this in native Rust. This is also a modification of another presentation, not my bachelor's thesis, but a presentation I gave about 1 month ago in ROSCON 22 conference in Japan. And these are some of our company slide backgrounds, but to give them some credit, these are not professional models, but software developers. And so those were Juho, Petteri, and Mariana, my colleagues. Today's topics: the robot operating system. Who has heard of it? Hands up, please. Okay, so some of you, but maybe not quite half. It's a framework for programming mobile robots. Then something more exotic, data distribution service. That's because that's the underlying technology in the current robot operating system, or ROS version 2. Then using ROS 2 from Rust, there are actually several alternatives, one of which we have created. And underlying that is something called Rust DDS, so it's a native Rust implementation of the data distribution service. And then some code, then our ROS 2 client, and some more code, and then some slides about the FlexBot robot framework that we have developed. It also talks to ROS 2, but I think it's more advanced in some senses. And then some examples. Since I'm here on company time, I have to give you a company presentation slide. So this is some of our staff some 5 years ago. I guess now our amount of staff has doubled, but the hallway is not any bigger, so we cannot update this photo anymore. And what we do, we are an engineering company. We build software for others. And we are located in Hervanta and in Espoo. Okay, but to the actual topic. So robot operating system, or ROS. This is a framework for making your own robot, or the software part of it. And most of this is communication between components or nodes. In ROS, nodes would typically be standalone processes which send and receive messages to each other. And they do this using something called topics. So you have named and typed topics, and you publish messages to topics, and you also subscribe to topics, so you get to receive all the messages sent by anyone to that topic, much like MQTT or some other publish subscribe protocol. ROS was initially started by the robotics community, or by some particular robotics project, which then eventually became a company, and nowadays parts of it are transformed to the open source robotics foundation, is it? Anyway, it's a US-based company who's the lead developer of ROS nowadays. And what you get in addition to the communication system, you get a lot of tooling for building your robot software. So in order to debug your robot and to see what went wrong, why it crashed to the wall, you need loggers and log analyzers. You need visualizers to show what the robot is thinking. You need all sorts of debug tools and build system, because typically you would be putting the software together from multiple packages, and most of those you did not write by yourself. ROS version 1 has become hugely popular, at least in the hobbyist and academic circles, not so much in the industry, because of the not so industrial strength implementation. So the internal communication protocol is a custom protocol which runs over TCP, which is not very good for real time, especially over Wi-Fi. So if you lose a packet, then timeouts start ticking, and time goes by and no communication happens. And also all the communication is via a central master node, which is a single point of failure, which is even worse if your robots are running over Wi-Fi, which they typically are, since at least these guys are not dragging Ethernet wires behind. These are examples of some commercially and semi-commercially available robot hardwares that you can buy and which can use ROS. And ROS2 was made specifically to fix these issues in ROS1 and to make it, let's say, more industrial strength software. So now it's instead of the custom protocol, it's based on something called data distribution service, which runs over UDP. Data distribution service is a piece of actually protocol specification and API specification from guys called Object Management Group. Those who were around in the late 90s or early 2000s may remember Object Management Group, or OMG. They are really called that. But I guess the acronym did not have such connotations back 20 years ago. Those were the same guys, I guess, which we should thank for UML and such niceties. Anyhow, ROS2 is programmed natively in C++ or Python, or the standard packages have APIs and tools for those, which we in the Rust community understand that we can do better. Going to the data distribution service, so this is the communication mechanism they are now using. So it's a publish subscribe. So you have something called communication topics, and a number of publishers can join a topic, and also a number of subscribers, here they are called writers and readers, can join. And each topic has a specific data type which is being published into that topic. And nice thing about DDS is that there actually are multiple wire-compatible implementations from different companies which are commercially supported. Another nice thing is automatic peer discovery. So just connect everything to the same network segment or the same broadcast domain that you can multicast over, and all the different processes over different computers will automatically connect as long as the topic names and types match. DDS will do data serialization and deserialization for you, so you don't need to choose your serialization format. It uses something called CDR, or Common Data Representation, which was designed by the Korba folks back in the 90s. It's still fairly usable, and you really don't need to touch and see it, so never mind. And it's a straight binary, fairly effective. So nothing like XML or JSON or nothing like that. One of the nice things about DDS, it's fully peer-to-peer. There's no central broker, no central servers whatsoever. And it can run in two reliability modes. So you have best effort mode, which is essentially like UDP with some extras, but you just fire packets away, and they are either received or not, but you don't stop and wait for any acknowledgements. So over an unreliable network, that's sort of the best real time you can do. And you can also have a reliable mode where samples are acknowledged and retransmitted if necessary, just like in TCP, but a little bit smarter. And the cool thing is about that in a single topic, you can have both best effort and reliable publishers and subscribers. So what do you get with DDS? This is just a summary of features. It can use multicast IP to reduce traffic. So if one writer is sending data to multiple subscribers, it needs to send the packet only once. You have the serialization. So from programming language, you send and receive your native data objects, and you don't need to mess with any deserialization library. and really funky quality of service settings. So you can ask DDS that, okay, please buffer the last 100 samples from here, and you can set best effort reliable. You can make your message durable, that if some subscribers are joining a few seconds later, they will still see the old messages. You can have heartbeats. You can also request callback notifications that, hey, that guy missed his heartbeat or missed the deadline. I mean, if some writer doesn't update the data per agreement. And you can do even coherency and ordering some sort of transactions over the wire. I'm not going there. ROS does not use any of that. Actually, ROS doesn't use most of these advanced quality of service features. Now, how to use ROS2, how to program your robots in Rust. There are several alternatives if you go Googling. This is what I came up by searching through GitHub. So there's sort of the official ROS2 Rust binding, I would say. So it's binding to RCL, which is the official ROS client library that's written in C. That's from the original authors. And then there's a thing we have cooked. It's made with Rust from the ground up, including the DDS implementation. And then there are these others which are also bindings to the original C language library. Okay, some words about Rust DDS. So this is mostly to show the communication stack we are running over. This is actually a fully generic picture. So the original ROS2 stuff fits into the exactly the same picture. So you have your ROS node up here, and if you publish some data, it goes to a publisher object where it goes through this stack of things down to network adapter, and finally somewhere else it climbs up the same stack. And what is actually meant by DDS, as in the standard name, is this API. Then here is the network protocol on top of UDP. It's called RTPS. So this is real-time publish subscribe protocol. This is also standardized by the OMG organization. And I've here put some alternative implementations. So if you are working with a C language, you can use, actually you should not do that, you use C++, you can use the RCL CPP library, or in Python use the Python version of the ROS2 client library. And these then may bind to one of these commercially available DDS implementations. And Rust DDS is one alternative here, but then of course you have to use ROS2 client, which is Rust also. I don't like FFI as much as the previous speaker. At least I try to avoid it. So here's how it works. This is sort of the Hello World program of DDS. So it's something called Shapes demo. All the vendors have this, and some even have a fancy user interface. The right side is not animated. This would be just the text line scrolling, because we don't have a graphical user interface. This is just printing the topic name and the data it receives. So this is the contents of one data sample. There's a string representing a color and some coordinates and I guess size in pixels. And this is Rust DDS then talking back and forth with this RTI implementation. So it's just exchanging data about the location and color and size of geometric objects. You can have squares and triangles and whatnot. Right. How do we do this? Since this is Rust meetup, so some Rust code. So in Rust, I have to define my shape. This must correspond to the structure that the C++ guys, I mean the other implementations are using. So we must have equivalent fields and in the same order. Naming of the fields does not matter, but the naming of the structure, well, this naming is internally to Rust, but when you connect to the topic, then you must have the same type name. Yes?
Question. Rust struct, the internals of a Rust struct are not guaranteed by any, there's no guarantee.
Yes, the ordering is not guaranteed, but the serialization takes care of that. Okay. The serialization serializes in the order that the fields are declared. I'm using the excellent Serde library. If anyone has used Serde, yes, right, yes, and you can make it do CDR also, although it may not be very pretty, but it can do even that. Okay. Then you start up. First you create something called domain participant. The main entity, so this represents the process which is going to join the DDS network. And then you do some polling and events. These are from the Metal.io library, which is part of the Tokyo framework. So this is just used for asynchronous I/O or polling from multiple input sources. And not really related to DDS in any way, but we have to use something for that. And from domain participant, you actually get a subscriber, and from a subscriber you get a reader, and the DDS API or the specification says that you must have a function which is called take next sample or something. I've taken some artistic license in implementing the DDS API because although it does not strictly specify a language, it's obvious a mile away that it's written for C++, and there are some horrible C++ things sticking out of it, and I have sanitized it a little bit because in Rust we can do better. Somebody recently complained to me on a GitHub that this actually should be named try take next sample because it returns a result, and inside that result or inside the OK it can return either some or none depending on whether any data was actually available. This is a little bit unexpected because the polling here triggered, so we should have some data available. I don't really even know how to cause this condition, but anyhow. And this is actually a line from the shapes example, so here it's printing the lines. So the name of the topic, which was a circle, and then the circle coordinates and other properties. Okay. Hello to Juho. ROS2 client is then built on top of Rust DDS. So what the ROS2 client library does is actually dropping functionality away from DDS because the DDS API is so complex that you don't want to use all of it, or the Rust guys didn't want to use all of it, so they made a simplified version and then added some functionality like event loops, which we don't do, but and they also, in addition to topics where you publish and subscribe, they have something called services, and services are like remote procedure calls, so you may make a request and then wait for reply, which you may eventually get if there's a server node somewhere which then receives the request and sends a reply. So there's a pair of request reply in services. Now, using ROS2 client, it's a fairly similar, only one page of code this time. So this is actually made to interface. One ROS2 standard example is just some chatter example, which is sending strings over to the other node. And you create a node because the domain participant in ROS2 is called a node for some reason. Then you create a topic, and from the node you also create a quality of service object because you have to have something. This is just the default constructor, so require nothing special. And here we give this magic string. This is according to the ROS2 specifications, so their standard strings are called this. Here we give string. This is the Rust string type, so we give it as a generic parameter, so we specialize the create subscription function here. And then we have a similar polling loop. Here's once you get triggered, you take a message, and if you get something, you can, for example, print it, and if you don't, then don't. I took some lines out of this just to simplify it for presentation, but you can go to GitHub and see. Yes.
So is there support for actions yet?
For actions, no. Support for services is, but actions are fairly straightforward composition of services, so it doesn't seem like a very great thing to add. Services were pretty tricky because services actually map something called remote procedure call extension on DDS, and it seems that the standard defines two different ways of doing it, which are incompatible, and then one DDS implementation has a third way, which is the current ROS default. So go figure. Okay, then this FlexBot thing, so which we have cooked within AutoStack. You could legitimately ask why on earth, but we started this before ROS2 was a thing, and so these softwares have been actually developed in different order than what I'm presenting. That's why it may seem strange. This is also a robot programming framework, and I'm sorry, not yet open source. I cannot show you the sources, but the main idea is similar to ROS2, except maybe a bit less dynamic, because I'm a big believer in static checking. You should check things statically whenever you can. And differences to ROS2 include that we have a whole software specification which is machine readable. And it is nicely machine readable because it's actually Haskell code. So I can use the Haskell compiler to read it and generate more code out of that. And we can do more closely coupled nodes than ROS2, so we can have a lower overhead in communication. We can transfer much more data and with a much higher frequency, especially if the nodes are close together, let's say in the same process, or in the best case they are in the same thread. So then it's just passing essentially pointers in memory and not even synchronizing. So to contrast these to ROS2, in ROS2 you have these nodes. These would be standalone processes and some topics connecting them, and you have your gears, your machinery, or your algorithms inside, and then you are sending and receiving. In FlexBot it's a little bit more complicated. So you have the specification on the left, and then your algorithms or message handlers on the right, and these are just imported, and then the actual software is generated from the specification and put together from these. And the plumbing you don't need to write manually, just write the specs. So what are the interfaces of the nodes and the types, and what are the connections between them, and how to generate them, so how to put them into different processes, different executables, and how to split the nodes into different threads, so you can have concurrency on many levels. And you can even change nodes to different threads by just changing the specification. No need to change your manually written code. So how this is done, I already mentioned that the specifications are Haskell code, so we can use whatever Haskell tooling. How many of you have programmed in Haskell? Wow. Well, not so many. I highly recommend that to Rust programmers because it's also very nice like Rust, although in different way. And you can see that many cool things you find in Rust are actually borrowed from Haskell, including the type system and parts of the type inference and what have you. The memory management in Rust is fairly unique, but a lot of other stuff comes really from Haskell, and it has a much neater syntax than Rust. Yeah, and for implementation and runtime, we are using Rust only, so Haskell only gets run during build time or code generation time, because Haskell is not that real time. It has a real generational garbage collection and everything. Actually, it's not that slow. We have managed to do real time machine control applications with it, so you can do it if you are careful. Or not even super careful, just pay some attention. And as an example, we have written an application to move a small Pulu robot. Pulu is a small robotics company from Tampere. And here I counted the number of code lines. So we have 18 different nodes to run the Pulu robot, do navigation and receive commands and have a console and do everything. And this is some 10,000 lines of code. But the cool thing here is that the boring part, which is all of this wiring, I have this less than 2,000 lines of specification, and from that I can generate something, I don't know, maybe 13,000 lines of very boring boilerplate code. And since this is generated, it can be somewhat error checked in the process, so I know that it's made very systematically. And it really generates 3 different executables, most of which are multi-threaded. And what do we get with FlexBot? So we can write code in Rust, much improved over C++. We get safety, we get real timeliness. That's not a word, I suppose. We get to write the specification in Haskell and it generates stuff for us. We can visualize our program structure, so we can generate graph ML, to which we can use graph layout programs to show it what it looks like. And also we can visualize and type check before execution. This is something you cannot do in ROS. Actually, even before programming, you need the spec only. Yes, and the specification assigns nodes to processes and threads, and you can most of the time code algorithms like you would be single-threaded, which simplifies stuff quite a lot. And synchronization is generated between nodes as needed and only as needed. So we have these different types. Actually, we have some more, but they are old and bad, and we could add some more. So we could use ROS2 communication over network. We can use Rust channels, which are fast, and even straight function calls, which are very, very fast. And we can change between these by changing the specification and regenerating the communication network code. Of course, you cannot do straight function call to another process, but within limits of reason. And all sorts of stuff you have here. Okay, then some examples. Hello, Petteri. So here's an example of the visualization. This is rather bad visualization for a presentation, but this is what you get straight out of a free graph layout tool. So you just put your specification, generate it, and you can view the program structure like this. You can do similar visualization in ROS2, but that requires you to have all the nodes running, and it will do introspection on the running system. And you can read here or you cannot read, but in unreadable font you have the names of the connecting ports, and you could have the types and customize the visualization somewhat. But on the left-hand side, you should see the 18 nodes which compose this pull robot thing. The pull robot thing looks like this. So let's see if I can get my videos running. So it's physically a box like that, and there are some Raspberry Pis. And here on the right, this is the RWITS program from ROS2, and it's just a straight install from binaries, completely unmodified, and we talk to it, and it thinks that it is visualizing a ROS2 robot. And the guy on the left-hand side is running fully Rust. Oh, well, there's some Arduino microcontroller also, which is running C, but let's forget that. Anyhow, these videos are not synchronized, so it's not very real time, but I just clicked play as quickly as possible. And why am I not getting? Here's another thing. So we tested this in Järvenpää just a couple of weeks ago. So this is an actual automated forklift, weighs about 1 or 2 tons, and it is running essentially the software stack shown on the right. So there are bits and pieces from several different companies, which were mostly developed separately, but we could put them together with ROS2, including our home-cooked Rust DDS and FlexBot, which is, well, here it's basically just acting as a hardware driver, but in any case. And this is part of a research project which actually is demonstrating this how to integrate and interoperate vehicle software from different vendors. Okay, and I guess then just some summary, but basically that's it. Back over to you, Henry, wherever you are. There.
Pass the microphone. Somebody.
Yeah, do we have questions? I think we do have still some time.
Yeah, I'm just curious, what was the motivation to write the DDS in Rust? There was already some DDS implementations. I know some of those were not too good, but what was your motivation for that?
Yes, the thing is that the DDS has to know the structure of the data because it has to do serialization and deserialization. And we wanted to use Rust generics for that. And the other guys are using C++ generics for the same thing. And it seemed to me that this is going to be a horrible mess of doing generics over FFI. So maybe it's easier to write the protocol from scratch. Turns out it was not very easy, but we finally did it. And now we have it, so just a lucky guess.
Yeah, thanks. Another question. So back when I used Rust2, there was a big selling point that those nodes could be run on microcontrollers. Have you done that or checked that functionality? The pull was
Rust2 on microcontrollers?
The nodes. There was some node support on microcontrollers, so have you tried that?
No, and ROS2, the standard distribution cannot be run on microcontrollers. There are some specialized microcontroller runtimes which are more or less compatible, but the standard distribution essentially requires that you run it on Linux.
Yeah.
So you have to switch to a different runtime and have a different who knows what different, but straight out of the box it does not run on microcontrollers.
Yeah. Anyone?
Everyone is completely baffled or too tired to ask anything. Okay, In any case, thank you for your attention. I used almost twice my allocated time, but everybody has been incredibly patient.
I think it was good.